Okay, I am going to prove the Pythagorean identity. Here's some important information. The equation for a circle centered at the origin is x squared plus y squared equals r squared, where r is the radius. The unit circle radius is 1, always. And on the unit circle, x equals the cosine of theta and y equals the sine of theta. Alright. Well, if we know that x equals the cosine of theta and y equals the sine of theta, then you can just plug that into the equation for the circle. Alright. Here's our equation for the circle. X squared plus y squared equals 1 squared. Remember that I replace r with 1 here because the radius on the unit circle is always 1. Now, if x equals cosine of theta, plug that in for x, and y equals sine of theta, you plug that in for y, you get cosine squared theta plus sine squared theta equals 1. Well, this is starting to look rather familiar. If you apply the commutative property, you get sine squared theta plus cosine squared theta equals 1. That is the Pythagorean identity. Now let's give an example to make sure this is right. Right, we're going to plug the point -1 into the equation for a circle. When you do that, you get this here. -1 squared plus 0 squared equals 1, 1 plus 0 equals 1, and 1 equals 1. This point works. Now, let's do the same thing, but this time using a Pythagorean identity. Alright, come down here. You plug your numbers in, and here's why you use 180 degrees. At the point -1, 0, this is 180 degrees. You have to use degrees because theta is an angle measure, not a coordinate point. Okay, so when you do this, the sine of 180 degrees is 0, and that's squared, because the 2 there, plus the cosine of 180 degrees is -1, and you square that because of the 2, and that equals 1. Then you get 0 plus 1 equals 1, and 1 equals 1. This works. This proves the Pythagorean identity works.